Hey guys, Mr. B here again, bringing you another math video. This one, of course, on adding and subtracting functions, and this is something that you probably walk into your calculus classes on your first day, and the prof might mention, this is in the first part of your textbook or whatever. Well, I spend usually a couple classes on this with my students, and the reason why I do that is because I think it's really important to be able to, when we do derivatives and things like that, to be able to differentiate what type of functions that we have. We have multiplying functions, we're dividing, we have composite functions. So it helps, to spend a little time on that stuff now, and that way it helps. We don't have to spend as much time on it later. So first one I'm going to talk about is adding and subtracting. So there's a little bit of notation and things to get out of your way here. My students will know adding and subtracting functions to look like this. Just f plus g of x and f minus g of x. Of course, you can know it just like this, f plus g, f minus g, and then you can have it as f of x plus g of x, or f of x minus g of x. So that's the notation thing. Not really that complicated, but important nonetheless. Alrighty, so let's have a look at an actual question and see how it goes. So what is f plus g of x? That's how you say it, f plus g of x. If f of x is x squared and g of x is the square root of x. So, this is not an overly complicated question, but it is important for finding the domain and range and things like that. So this is a good example in that case. So f plus g of x, so it's the same as f plus g, and of course my f is x squared, and my g of x is the square root of x. So if there was like terms here, we could add those together, but there's not a whole lot we can do with that, so we're just going to leave it alone. Now if this question elaborated a little bit and asked us to find the domain, we'd have to look a little bit deeper into this guy. So for adding and subtracting functions, the domain is the intersection of the two functions. So I'll write that out if I can spell it. The intersection of the two functions. So intersection has this symbol, upside down U, and it's a fancy word for overlap. So where does the domain of the two functions overlap? So where are they both the same? So in order to sort of examine the domain of f plus g of x, we need to look at f of x and g of x separately. So let's look at f of x. So f of x is just x squared, so that's a base quadratic, which has the domain x belongs to all real numbers. X can be anything, there's no restrictions on it whatsoever, just like all quadratics. G of x, of course, is a square root function, so your base square root function. Now we all know that we can't take the square root of a negative, so what's underneath the root sign has to be 0 or greater than 0. So x can be 0 or positive. So I have x such that x, oops, la-di-da-da-da-da-da. Alright, here we go. X is greater than or equal to 0, and x belongs to all real numbers. So if you look at this guy, really, since x squared can be anything, in terms of your x can be anything, and this guy is really going to be your limiting domain, so to say. So really, when I look at what overlaps, well, this has the positive numbers, so does this one. So 0 and everything greater than 0, and then 0 and everything greater than 0. So the domain of this guy is going to be x such that x is greater than or equal to 0, and x belongs to all real numbers. So that's how you find your domain. You want to look at your intersection of the two functions. Where does it overlap? Alright, so let's have a look at a graph of f of x and g of x, not the same ones we had in the last time, two different ones, and see how we could find the actual graph of f plus g of x. So what I usually do is I make a chart, but I'm not going to do that in this case. I just don't have the space for it, and it would take a long time on this video. But what you could do is make a chart that consists of x, f of x, g of x, and then f plus g of x. So I'll just do one and show you, I guess. So if I look at, this is a good place to start because I have 2 points here at 1, x is equal to 1, so f of x is 6, and g of x is negative 3. So let's just do this one. So if I had a little chart here like this, I choose my x value, my f, my g, and my f plus g. So that will be my chart, and I choose a value for x, so now I'm choosing negative 1. And my f value is all the way up top, which is 6. My g value is negative 3. So therefore my f plus g value, I just add those two together, and I just get 3. So that's what I'd plot on the graph. Negative 1, and then 3. So that would give me what I put on the graph. Now, chances are this is not going to be a long answer question on the calculus exam, so it's a good multiple choice question, if at all, really. But anyway, it's a fundamental to understand what's going on here. So I got 6, negative 3. I add them together, I get 3. So I'd have a dot right here at 3. I'm going to get rid of those other dots just so I don't want to confuse myself here. And then here, the next one at 0, I have positive 1 and negative 2. Add those together, I get negative 1. At 3, I have negative 1, negative 2. Add them together, I get negative 3. The next one, I have 0 and negative 3. So that's 0 plus negative 3 is 0. Or negative 3, sorry. Then I have 1 plus negative 2. So then I'm going to have 1 plus negative 2 is negative 1. So you sort of see the pattern that's emerging here. And then the next one is 1 and 2. So let's back up to 3. So you know it's going to be kind of hard for me to sketch this on a computer. But anyway, let me give it a shot. So it's going to look like a quadratic. Oh my god, horrific. It's going to look like a quadratic. It's going to have a U shape to it. Just like, actually not too bad. Just like that. So that is what we have for our f plus g of x graph. And you can see that f and g didn't have any restrictions on the domain, all real numbers. So therefore, f plus g of x doesn't have any restrictions on the domain. So hopefully, guys, this makes a little bit of sense to you. Again, in order to get good at this stuff, you got to do questions. So if you got questions, feel free to ask. I'll see some of you guys in class. Good luck.